Tangent radius property, practice number 13. Point Y is the point of tangency to the circle. Determine the values of E, which is line W to Y, and F, which is line Y to Z, to the nearest hundredth. Since point Y is the point of tangency to the circle, line W to Z will be our tangent line. Line O to Y will be our radius, as we're going from the center of the circle to touching the circle. Using the tangent radius property, we know that when a radius and tangent meet at a point of tangency on a circle, this will always create a 90-degree angle. Let's redraw this right angle triangle and put in the dimensions that we know. We know the angle on the bottom right is 90 degrees. We know the value of this line here is 15 centimeters, and the value of this line is 7 centimeters. What we don't know is the bottom line, which is E. Since this is a right angle triangle, we'll use Pythagorean theorem to solve, which is a squared plus b squared equals c squared. Our C will be our line opposite of the right angle, which will be 15 centimeters. We'll call the bottom line A, and the 7 centimeters can represent our B. So a squared plus 7 squared equals 15 squared. We don't need to use two variables, so instead of using A, we'll use E. So instead of a squared, we'll use E squared. So E squared plus 7 squared equals 15 squared. 7 squared is 49, and 15 squared is 225. Next, we have to remove the 49 from this side. We do this by subtracting 49. If we subtract 49 from this side, we have to subtract 49 from the other side as well. The plus 49 and minus 49 will cancel, leaving us with E squared. And 225 minus 49 will equal 176. Next, we need to get the E by itself, so we need to remove the squared from E squared. To do this, we'll take the square root of E squared. If we take the square root of this side, we need to take the square root of the other side as well. The square root and squared will cancel, leaving us with E, and the square root of 176, rounded to the nearest hundredth, is 13.27. So E will equal 13.27 centimeters. Now let's solve for F. The tangent radius property applies to this triangle as well. So this will also equal a 90-degree angle here. Let's take this right angle triangle and redraw it and put the dimensions in that we know. We know the angle on the bottom left is going to be 90 degrees. We know the value of this line is 9 centimeters, and the value of this line is 7 centimeters. What we don't know is the bottom line, which we'll call F. Since this is a right angle triangle, we'll use Pythagorean theorem to solve, which is a squared plus b squared equals c squared. Our C will be our line opposite of the right angle, which is 9 centimeters. We'll call the bottom line A, and the 7 centimeters can be our B. So a squared plus 7 squared equals 9 squared. Since we have two variables, we'll stick with the F, as that's what we're trying to solve, so we'll remove the A. And instead of a squared over here, we'll put F squared. So F squared plus 7 squared equals 9 squared. 7 squared is 49, and 9 squared is 81. Next, we have to remove the 49 from this side. We'll do this by subtracting the 49. If we subtract 49 from this side, we have to subtract 49 from the other side as well. The plus 49 and minus 49 will cancel, leaving us with F squared. And 81 minus 49 will equal 32. Next, we need to isolate the F and get it by itself. To do this, we'll do the opposite of squaring F. So we'll take the square root of F squared. If you take the square root of this side, but you take the square root of 32 as well. The square root and squared will cancel, leaving us with f. And the square root of 32, rounded to the nearest hundredth, is 5.66. So f is equal to 5.66 centimeters.